several questions. Questions?
I'm a bit of a skeptic when it comes to the exascale, really, because you can't say that every problem is parallelizable, because I've written programs for hundreds of thousands of cores, and if the problem is not simple in a sense that it requires a lot of communication, you end up with all of your time spent on communication, not on the actual computation. So there still are problems, and probably many real-life problems are the ones that cannot be parallelized to the exascale.
Okay, so let me answer that. So you're correct, there will be some problems that cannot be parallelized. But remember what I said about real dependencies and accidental dependencies. So if you're familiar, so there's a law called Amdahl's law, which governs performance. And basically what it says is when you've broken things down to the smallest possible unit, as I did with the bricklayers, then fundamentally adding any more workers isn't going to get any faster. So you've already seen an illustration of that on a small scale. So you're quite right, there are some problems that won't break down. The question then is, can we find ways to break them down? Can we use tricks to eliminate some of these dependencies which appear to be essential, but actually in practice are not? And one of the tricks that we can use, especially in the functional programming context, is immutability replication. So one way to reduce communication is to, for example, replicate data. To do things multiple times, you may pay more computation cost, but you reduce communication cost. We need to keep that in balance, because you've correctly identified that in these large-scale systems, what matters partly is how much data you're shifting around the system.